So in the previous class, we have discussed about the Norton's theorem, and I told that Norton's theorem is dual of this Thevenin's theorem. Okay, and Thevenin's and Norton's theorem are dual to each other because in Thevenin's theorem we can see that any network can be converted into in any network in between any two terminals we can resolve the network in a single voltage source and in series with that single impedance. Okay. Similarly, in Norton's theorem, it is simply voltage source to current source conversion, and we can convert that series connected voltage and impedance, voltage source and impedance into current source, and the value of current source will be the voltage value divided by impedance value. VTH is equal to VTH divided by ZTH. That will be Norton current, and in parallel to that Norton current, you have to use the same impedance that you have obtained. Okay. So we have seen the same example by using Norton's theorem as well. So if you have any doubt, you can ask. Otherwise, we can proceed to the next theorem. So are you trying to solve the problems given in the examples? Hello? Ankit, Aditya, Samyak, Ritik, Sambhavi. Are you trying to solving the questions given in the example? Because you have to apply the theorems, and based on that answer is given here, so you can verify your answer. Not trying? Hello? Can you hear me?
Yes, sir.
Okay, so are you trying to solve questions given in the example? Have you tried? No. Or is there any issue in the understanding of the theorems, how we can apply theorem? Is there any doubt in superposition theorem, Thevenin's theorem, and Norton's theorem? And how is your tutorial class going on? It's very bad that you are not telling anything. Tutorial class are going good. Okay. Okay, fine, fine. And what about this course? Is there any doubt? No doubt. Okay, then I will move to the next theorem, that is maximum power transfer theorem. So as the name suggests, maximum power transfer theorem means it will provide the maximum power that will be transferred from source to load. Okay. In any circuit, you can see that there are some sources and there is some load. Okay. So in between that, some network is there. So how much power is being transferred from source to load, that will be decided by maximum power transfer theorem. And we can identify the condition for the maximum power transfer between source to load. Okay, so in most of the cases, in most of the practical applications, we should know about the how much power can be transferred to the load from the source. Okay, in most practical conditions, we should know how much power can be transferred to the load from the source side. Okay, we cannot predict the higher power as compared to the input power. Okay, as compared to the source, means whatever the source is delivering power to the load, that cannot be achieved as per the boundary of the source, means as per the capacity of the source. If the source has a capacity of 200 watt, so it can provide output power to the load within that limit. Okay, it cannot provide 220 watt, 230 watt. Okay, based on the capacity of source, we can get the maximum power, or we can achieve the maximum power being transferred to the load. Okay, so in other words, we can say that what is the value of load resistance, and that will absorb the maximum power from the source. Okay, so in other words, we can also calculate the value of load resistor that will absorb maximum power being transferred from source to load side. Okay, so suppose it is directly or indirectly related to the application of Thevenin's theorem only. So let us consider an electric network here. And in this problem, we have to find the choice of the resistance RL so that the network delivers maximum power to the load. Or in other words, we can say that what value of load resistor will absorb maximum amount of power from the network. So we can see in this network, there is a DC network including the source. It is including the source. And there is a load resistor here. We have connected load resistor. This is your load. And here source. Source is inside this DC network, DC resistive network. So power is being transferred from the source side to the load side. So what will be the condition for the maximum power being transferred from source to load side, that we have to identify and analyze. Okay. So the problem can be solved with the help of Thevenin's theorem, because we know that the power can be derived at load power will be IL square into RL simply. Okay, because if the current flowing through this branch is IL, so power will be IL square into RL. So what will be the maximum power, and what will be the expression for maximum power transferred from source to load, that we have to identify. Okay, so for that we can apply Thevenin's theorem, and we can resolve this DC resistive network. And how we can resolve by using Thevenin's theorem? We can resolve with a series, voltage source in series with the impedance. Okay, that will be equivalent impedance. So by applying Thevenin's theorem, we can resolve this network in a single voltage source and single resistor, because we have assumed the resistive network here. So this network can be resolved into single voltage source and in series with that resistor. And the value of load current we can calculate here. IL is equal to VTH divided by RTH plus RL. Okay, and the power you can see here, it is given IL is equal to VTH upon RTH plus RL, that is power through the load resistor RL. Current through the load resistor RL. IL is equal to VTH upon RTH plus RL. What is the power delivered to the load? Power delivered to the load PL is equal to IL square R, IL square into R. So IL square is nothing but VTH upon RTH plus RL whole square into RL. Okay, so this is the expression for output power being delivered to the load. So the load power depends on the both RTH and RL. You can see here, load power is depending on both RTH and RL, where RL is variable. Okay, load resistor is variable. RTH is constant based on the application of Thevenin's theorem, and based on the network, we will get RTH value, that is Thevenin equivalent resistance, Thevenin resistance value or equivalent resistance value. So the power delivered by the equivalent Thevenin network to the load resistors entirely depends on the value of RL. Means based on the value of RL, it is only variable quantity. So how we can calculate the maximum power being delivered to the load? So to maximize the power, we know that we have to use maxima minima principle. For that, we have to differentiate this load power with respect to the variable. And what is the variable here? Variable is load resistor. So that's why dPRL divided by DRL, we are differentiating with respect to the variable, that is load resistor RL. So you know that this is, if we expand, this will be VTH square RL divided by RTH plus RL whole square. Okay, so dPRL divided by DRL will be equal to VTH square is the constant term, RL is only variable. So we know that this is differentiation is in the form of P by Q. Okay, so both are the function of RL. So if we differentiate with respect to RL, okay, so VTH square into denominator quantity, differentiation of numerator. So denominator is RTH plus RL square into numerator is RL. So using partial differentiation, we can get dRL upon RL will be 1. So we will get RTH plus RL whole square only, minus of this RL means numerator and multiplication of differentiation of denominator. So minus of 2RL means if we differentiate this one with respect to RL, so using partial differentiation, 2 into RL into RTH plus RL, and then if we differentiate further this part RTH plus RL, it will be 0 and it will be 1. So that's why we will get in the numerator this much divided by denominator square, RTH plus RL whole square. Okay, means RTH plus RL whole square was there already. So this square will be whole to the power 4. RTH plus RL power 4. That will be 0. So if we equating 0, then we will get the condition for maximum power being transferred from the source to load side. Okay, so by equating this one, we can see that if numerator will be 0, this whole quantity will be 0. So RTH plus RL is the common here, you can see. So RTH plus RL can be taken common. So here we will get RTH plus RL minus 2RL is equal to 0. So RL is equal to RTH. Means load resistor value will be equal to Thevenin resistance value. Okay. So it means maximum power dissipation. For maximum power dissipation to load, condition must be satisfied. Means we have to see the value of RL, whatever we are getting, it gives maximum power or minimum power. Okay. So for that we have to use double differentiation. So D2 PRL divided by DRL square, and where RL is equal to RTH we will put. So we are getting minus VTH square upon 8 RTH. That will be negative value. So if double differentiation is negative, we will get maximum value. Okay. So that's why for this point, or for this value of RL, we are getting maximum value of power. So that's why it will give maximum power at this particular condition. Okay. So it means, so load resistance matches the Thevenin's resistance RTH for a given system. So that's why it is called as a load matching. And according to the Thevenin's theorem, the maximum power can be represented by P max is equal to VTH upon RTH plus RL whole square into RL. And by putting the value of relation of RL is equal to RTH, we can write, if RL is equal to RTH, we can write here 2 RTH. So 2 RTH square is equal to 4 RTH whole square. And this RL can be represented by RTH. So 1 RTH will be cancelled out. So we will get VTH square upon 4 RTH. So that means P max is equal to VTH square divided by 4 RTH. And at what condition we are getting maximum power? RL is equal to RTH. Means when load resistance value will be equal to Thevenin resistance value, in this case we will get maximum power. Okay. So it means that Thevenin voltage source itself dissipates as much as power in its internal resistance RTH. So efficiency under maximum power transfer condition, if we calculate, we know that the efficiency is represented by eta. So efficiency is equal to power output divided by power input. So power output is nothing but IL square into RL, and input power is 2 IL square into RL. Because we can see here, this is IL square RL, and power dissipation through this RTH will also be IL square into RTH. So RTH is equal to RL for maximum power. So it will be also RL. So IL square RL, IL square RL means source must deliver power twice of IL square RL. So that's why we are representing here twice of IL square RL. It means efficiency of the system is 50%. So efficiency is 50% means for maximum power transfer, efficiency of the system will be 50%. Okay. So by varying the load resistor RL, the power delivered to the load varies. So you can see the graph between power and load resistor. Because load resistor is variable, so if you increase the load resistor, power will slowly increase. and it will reach at the maximum point. And what is the maximum point? You will reach power at maximum point when RL is equal to RTH. So at RL value, RL matches the RTH, you are getting maximum power here. So this is the graph between power and load resistor. Okay, so the Thevenin equivalent circuit is useful in finding maximum power that a linear circuit can deliver to the load. Okay, so because we are using the Thevenin's theorem in this particular theorem, that is maximum power transfer theorem, so we can analyze that Thevenin's equivalent circuit is useful to find out the maximum power being delivered from the load to from the source to load side. Okay, so if you have any doubt, you can ask. Otherwise, we can go for a problem. Have you any doubt? This theorem is just an application of Thevenin's theorem. Okay, we are directly applying Thevenin's theorem to resolve the network, DC network. And after that, we are calculating the value of IL, that is current flowing through the load resistor. Load resistor is variable. So to get the maximum power from the source, we have derived the relationship for the maximum power and VTH and RTH. Means maximum power is depending on the Thevenin voltage and Thevenin resistance. And at maximum power, load resistor should match to the Thevenin resistor. Means the maximum power will be transferred from the source to load when the equivalent resistance or Thevenin resistance will be equal to the load resistance. If you have any doubt, you can ask. Okay, so we will take an example and we will try to solve the problem. Okay, so I will take this example first. Find the circuit shown in the figure below. Okay. For the circuit shown in below, find the value of RL that absorbs maximum power. Okay. Maximum power from the circuit and the corresponding power under this condition. So this is a quite complex network. It is given to us. Okay. So where we have to find the value of RL that absorb maximum power from the circuit and corresponding power under this condition. So we have to calculate condition for RL also. What will be the value of RL? And then we have to calculate the value of maximum power also. Okay. So RL is variable here. So we can see that we have to apply Thevenin's theorem, and according to that Thevenin's theorem, we can see that we know that already that the element in between the two nodes that is connected here, firstly we will remove. Okay. So and to
हमसे कही किसी ने हमसे कही नहीं मैंने पिछले कल निकाला था ये तो। हम्म
okay, so ultimately we know that for maximum power we have to apply Thevenin's theorem. To calculate VTH and RTH, because here the resistive network only we can see. So how we can solve? We have to calculate the value of VTH. So first we will redraw the circuit. Okay, this is 5 ohm. 5 ohm minus plus 20 volt. This is 5. This is 5. This is 10. This is minus 10. 10 volt. 10 ohm. And from here there is a current source. In parallel with that current source, resistance is there. So can we convert this combination into a voltage source in series with the same resistor? Can we convert into voltage source? Can we convert this current source into voltage source? It will simplify our circuit. क्या आप लोग कुछ बोल ही नहीं रहे हो, क्या बात है? If there is no response, so it will be very difficult for me also to teach. can we convert this combination into voltage source? Because this is a current source, we know that current source to voltage source conversion, how we can convert current source into voltage source? Okay, so we know that a current source in series with any impedance or resistance can be converted into voltage source in series with the same resistor. And the voltage source value will be, this is I, sorry. Voltage source value will be I into R, and same resistor will be there. So similarly, we will convert this current source into voltage source. And you know that the current direction is in this upward direction. So we have taken minus here, plus here, because in sources we can see that the current will flow from lower potential to higher potential. So that's why here also minus plus we have to take, and the current voltage value will be, voltage source value will be how much? Resistance
20.
will be same. What will be the voltage source value? 20 volt, because 2 ampere current source is there and 10 ohm is connected in parallel with that 2 ampere source. So resistance multiplied by current, that will be the value of voltage source. 2 into 10 is equal to 20 volt, right? 20 volt. So we have disconnected RL from here. So we have to apply Thevenin's theorem here across these two terminals A and B, and we have to first calculate VTH, okay, in between these two terminals. How we can calculate VTH? We have to solve the remaining network, okay, we have to solve the remaining network. So what about this network? How we can solve this circuit to calculate value of VTH? कौन सा थ्योरम अप्लाई करेंगे?
नोडल एनालिसिस।
नोडल एनालिसिस, ठीक है, नोडल से भी हो जाएगा।
सिंपल मेश भी तो कर सकते हैं ना,
मेश भी कर सकते हैं, राइट, क्योंकि
कि दोनों इंडिविजुअल मेश है,
हाँ, दो मेश बन रहे हैं, दोनों इंडिविजुअल मेश हैं, उससे भी कर सकते हैं।
करंट का एक्सचेंज नहीं होगा, उससे डायरेक्ट हो जाएगा।
कौन सा मेथड लगाएं, जो बता दो।
मेश वाला ज्यादा आसान रहेगा।
मेश वाला लगाते हैं, ठीक है। तो यहाँ पे हम देख रहे हैं, दिस इज 20 वोल्ट, दिस इज ऑल्सो 20 वोल्ट. So we will apply first mesh analysis. So we are taking current in mesh 1, that is I1. Current in mesh 2, ये mesh 2 है, that is I2. Okay. So we have to write KVL equations. For that, first we have to denote the polarity of voltage drop in the resistor. So ये 5 और 5 तो वैसे 10 ओम हो जाएंगे, सीरीज कॉम्बिनेशन है, बट इंडिविजुअल ही लिख लेते हैं. सो करंट इज फ्लोइंग इन दिस डायरेक्शन, सो इसके क्रॉस वोल्टेज ड्रॉप होगा प्लस यहाँ पे, माइनस यहाँ पे, राइट. यहाँ पे भी प्लस यहाँ होगा, माइनस यहाँ होगा, इसमें भी यहाँ पे प्लस होगा और यहाँ पे माइनस होगा. सो इफ विल अप्लाई KVL इन दिस लूप 1, so by applying KVL in loop 1, यहाँ पे भी करंट मीन्स वोल्टेज पोलैरिटी डिनोट कर लेते हैं। यहाँ पे करंट इधर है तो प्लस माइनस यहाँ होगा, और इधर भी जा रहा है तो ये प्लस होगा, ये माइनस होगा। ओके, सो बाय अप्लाइंग केवीएल इन लूप 1, यहाँ से स्टार्ट करते हैं, यहीं पे वापस आ जाएंगे। सो प्लस माइनस इज -20, देन प्लस माइनस इज -5, then plus minus is -5, sorry, 5i1, 5i1. Okay, and then this is plus minus -10i1 -20 is equal to 0. So ultimately you can see that how many i1 are there? 20i1 is equal to -40. So i1 is equal to -2 ampere. Okay, now by applying KVL in loop 2, so we can start at this point, we will move in clockwise direction, and again we will reach at this point. So plus to minus, -10i2, -10i2, then minus to plus, +10, then plus to minus, -10i2 is equal to 0. So यहाँ से i2 हम निकाल सकते हैं, i2 will be equal to, this will be -20i2 is equal to 20i2 is equal to 10, so i2 is equal to 0.5 ampere. क्लियर? यहाँ तक क्लियर है? Is there any doubt? We have calculated the value of i1 and i2. So what will be the value of VTH? VTH is polarity plus minus, यहाँ पे लेंगे. So what will be the value of VTH? कैसे कैलकुलेट करेंगे? How we can calculate the value of VTH? हमने i1 i2 तो कैलकुलेट कर लिया.
VA माइनस VC प्लस VC माइनस VB करेंगे तो निकल जाएगा.
हाँ, इट मीन्स हमको एक केवीएल यहाँ पे अप्लाई करना पड़ेगा इस वाले में, राइट? मीन्स इसके क्रॉस वोल्टेज लेना पड़ेगा, इसके क्रॉस वोल्टेज, ये वाला वोल्टेज भी आएगा. सो यहाँ पे केवीएल अप्लाई करेंगे तो हमको VTH मिल जाएगा. सो यहीं से स्टार्ट करते हैं, B to A चलते हैं, फिर वापस, या यहाँ से स्टार्ट करते हैं, क्लॉकवाइज में ही चलते हैं. सो -2 + 20 मीन्स अप्लाइंग KVL इन, ये लूप तो नहीं है, अप्लाइंग KVL फॉर VTH. अप्लाइंग KVL फॉर VTH. सो यहाँ से स्टार्ट करते हैं, माइनस प्लस प्लस हो जाएगा, +20, एंड देन माइनस प्लस 10i1, देन माइनस प्लस 10i2 माइनस VTH इज इक्वल टू 0. बिकॉज यहाँ पे हम चलेंगे, पहले प्लस मिला है फिर माइनस मिला है. सो इफ वी सॉल्व further, VTH will be equal to 20 + 10i1 + 10i2. अभी i1 i2 का वैल्यू पुट कर देंगे. 20 + 10 into i1, what was the value of i1? -2. So 20 + 10 into -2 plus 10 into i2 is equal to 0.5. So that will be equal to 20 minus 20 plus 5. That is VTH is equal to 5 volt only. So we have evaluated the value of VTH. Now we have to evaluate the value of RTH. for RTH, we have to again redraw the circuit, this circuit, by eliminating all sources. Okay, so this current source we have converted into voltage source, so we can eliminate these sources. 1, 2, 3, 3 sources are there in this circuit. So by eliminating these voltage sources, we know that independent voltage sources, ideal voltage sources will be short circuited. So इसको short circuit करेंगे, इसको short circuit करेंगे, इसको short circuit करेंगे. So our circuit will look like एक रजिस्टर और है यहाँ पे. दिस इज AB. हमको यहाँ पे RTH फाइंड आउट करना है और ये R इक्विवेलेंट होगा. And one 10 ohm resistor is also there across. Ten, 5, 5. यही था. 5, 5, 10, 10, 10. These sources, voltage sources are short circuited. Voltage sources here short circuited. Here also voltage sources short circuited. So what will be the equivalent resistance? Can you tell me what will be the value of equivalent resistance directly?
10 ohm.
Yes, 10. These are series. These are in series combination 5 and 5. So it will be 10 ohm. 10 ohm and 10 ohm are parallel. So equivalent parallel combination will be 5 ohm. Here also 10 and 10 ohm are in parallel. So 5 ohm will be their equivalent resistance. So 5 ohm and this 5 ohm will be in series. Okay. So equivalent resistance or Thevenin resistance will be 10 ohm. So if we further resolve, this can be resolved into this. This will be 5 AB. This is 5, 10, 10 RTH. This can be further resolved into 5, 5 AB. This is 5. This is 5. So RTH. RTH will be equal to 10 ohm. So RTH will be equal to 10 ohm. Okay, so we have evaluated VTH here. VTH is 5 volt. And RTH we have evaluated, that is 10 ohm. So what will be the condition for maximum power? Condition for maximum power transfer. RL must be equal to RTH. So it means what will be the value of RL? RL will be equal to RTH, that is 10 ohm. So we got our first answer. What was the answer? RL is equal to 10 ohm, right? We are getting 10 ohm only. Now we have to calculate maximum power. P max by formula P max, we can see that VTH square divided by 4 RTH. So what what is the value of VTH? VTH we are getting 5 volt. So 5 into 5, VTH square is equal to 5 into 5 divided by 4 into RTH, that is 10. So 25 divided by 40. So 5 by 8. 5 by 8 means 0.625. Zero 0.625 watt. That will be maximum power. Okay, whatever means the same we are getting here, 0.625 watt, and RL is equal to 10 ohm. So in this way you have to apply the Thevenin's theorem to calculate the value of maximum power being transferred from source to load side. Okay, so I think you can clearly understand this concept and how we have to solve these problems. You can practice more problems and you can verify your answers. Okay, so there are 2 more problems as an example given here. Answer is also given here. So you have to practice these problems and you have to verify your answer. Okay, as a homework, I am giving you this problem, that is application of network theorems with dependent sources. Okay, network theorems with dependent sources. So I am giving you this as an assignment for you, as a homework for you. This is as homework for you. Okay, you have to apply superposition and Thevenin's theorem to get the value of current flowing through 10 ohm, that is I naught. You have to calculate the value of I naught, and this is for your homework. You have to apply 2 theorems, superposition theorem as well as Thevenin's theorem, right? Understood? And there is dependent source here. You can clearly see this is a dependent current source, and it is depending on the current value in a branch, that is I naught. I naught is here. It is directly depending on I naught. So that's why this is what is the category of this dependent source? Which type of source is this?
Current dependent current source.
Right, current dependent current source or current controlled current source. Okay, CCCS. In short, we call it as a CCCS, current controlled current source. We have current controlled current source, current controlled voltage source, voltage controlled current source, voltage controlled voltage source. So we have these 4 types of dependent sources. We already know, we already covered this part. And what are the types, what are their nature, we already know. Okay, based on the means they are generally represented using diamond shape. So in that diamond shape, if it is a current source, the current direction is represented. If it is a voltage source, the polarity will be represented plus minus. Okay, and this 4, you can see here, this 4 is just a multiplier, constant value for I naught. For I naught means it is depending on I naught with multiplication of 4. Okay, so this value is 4 I naught. So there is a single dependent source, 2 independent sources are there, one current source and another voltage source. Okay, we know that if we apply superposition theorem or any theorem using dependent sources, so we can remove only independent sources. We will not touch dependent sources. We will solve the network by considering dependent sources also. Okay, we have to resolve only we can disable or we can eliminate only independent sources. So there are 2 independent sources here, 6 ampere and 30 volt. If you apply superposition theorem, you have to take independent sources at a time. एक बार में एक ही independent source को लेना है और उससे करंट वैल्यू फाइंड आउट करना है, हमको आई नॉट फाइंड आउट करना है. तो आई नॉट हम कैलकुलेट करेंगे बाय कंसीडरिंग ईच सोर्स एट अ टाइम. एक बार में 6 एम्पियर लेंगे, आई नॉट कैलकुलेट करेंगे. दूसरी बार में 30 वोल्ट लेंगे, आई नॉट कैलकुलेट करेंगे. और वो दोनों सर्किट सॉल्विंग के टाइम पे डिपेंडेंट सोर्स एज इट इज पड़ा रहेगा, उसके साथ ही हमको सर्किट को सॉल्व करना है. क्लियर? सो इस टाइप के प्रॉब्लम को डिपेंडेंट सोर्स के साथ अगर सॉल्व करना होता है, सो डिपेंडेंट सोर्स को हम टच नहीं करते हैं, उसके साथ ही सर्किट को सॉल्व करते हैं. राइट? इफ यू वांट टू अप्लाई थेवेनिन्स थ्योरम, सो हमें यहाँ का करंट फाइंड आउट करना है. ये 2 नोड एज्यूम कर लेंगे, नोड ए एंड बी. वी विल एज्यूम नोड ए एंड बी इन बिटवीन दिस एलिमेंट थ्रू विच वी हैव टू कैलकुलेट द करंट वैल्यू आई नॉट. और उसके बाद इसको हम रिमूव कर देंगे यहाँ से. जब हम रिमूव कर देंगे, सो इन बिटवीन दिस terminal, these 2 terminals, we have to apply Thevenin's theorem. So we have to calculate open circuit voltage or Thevenin voltage across these 2 terminals and equivalent resistance in between these 2 terminals. Clear? So you have to try this problem in your home and we will discuss in the next class. Okay, this dependent source problem. And okay, I will send you the next tutorial, tutorial 3, by today only, and you can practice the tutorial problem. And for any doubt, it will be discussed in the next week, Monday, that is in your tutorial class. Okay, I'm taking your attendance. Ashish, Abhya,
Present, sir.
Aditya,
Present, sir.
Akash,
Present, sir.
Akhilesh,
Present, sir.
Akshit,
Present, sir.
Ankit,
Present, sir.
Apurva.
Present, sir.
Okay, Arnav, Avinash.
Present, sir.
Arnav.
Yes, sir.
Okay, Avinash, Ayush,
Present, sir.
Gaurav, Ishant,
Present, sir.
कृष्णा?
Yes, sir. Ishan present.
ओके, ईशांत। कृष्णा?
Present, sir. So
मैथ?
Gaurav present.
गौरव प्रेजेंट, बोले नहीं उस टाइम। अविनाश? नहीं है। मैत्री?
Present, sir.
मुद्रा?
Present, sir.
प्रांजय?
प्रेजेंट सर।
प्राची?
Present, sir.
प्रज्वल?
Present, sir.
प्रियांश?
प्रेजेंट सर।
पुलकित?
प्रेजेंट सर।
राहुल? पुलकित इज ओके। प्रियांशु?
Present, sir.
राहुल? राजीव? ऋषभ आर्य?
Present, sir.
रोहन?
Present, sir.
रोहन,
Yes, sir.
बहुत दिन बाद क्लास ज्वाइन किए।
सर वो मैं रिकॉर्डेड लेता था सर, वो नेटवर्क इशू की वजह से थोड़ा नेटवर्क नहीं आता मेरे एरिया में।
कहाँ पे हो? नेटवर्क नहीं आता है? मोबाइल में तो आता ही है।
थोड़ा वो विलेज का एरिया है ना सर, थोड़ा नहीं आ पाता था। वो सर एक दो क्लास में ही खत्म हो जाता है पूरा, फिर उसके बाद रिकॉर्डेड लेता था।
ओके ओके ओके, हाँ ये थोड़ा इशू है। तो वीडियो ऑफ करके ही तो हो रहा है ना, फिर भी नेटवर्क चला जा रहा है इतना ज्यादा।
सर वो 1.5 GB मिलता है, उसमें तो नहीं हो पाता सर।
हाँ ये प्रॉब्लम है, लिमिटेशन है। एस ऋतिक?
प्रेजेंट सर।
साकेत?
प्रेजेंट सर।
सम्यक?
Present, sir.
संग्राम? शशांक?
प्रेजेंट सर।
शुभम?
प्रेजेंट सर।
दोनों शुभम हैं? शुभम रंजन,
यस
शुभम?
सर, प्रेजेंट सर। शुभम रंजन प्रेजेंट सर।
हाँ।
शुभम सिंह प्रेजेंट सर।
सृजन?
प्रेजेंट सर।
सुधांशु?
प्रेजेंट सर।
सुजीत? सुमित सिकरवार? सुप्रिया?
Present, sir.
सूर्यांश?
Present, sir.
उज्जवल?
प्रेजेंट सर।
उत्कर्ष?
प्रेजेंट सर।
वैष्णवी? वेदांशी? विशाल?
Present, sir.
वेदांशी?
Yes, sir.
विशाल?
प्रेजेंट सर।
यश?
प्रेजेंट सर।
विनीता?
Present, sir.
संभवी?
Present, sir.
ओके, एनी अदर?
सर मैं क्लास कर में प्रेजेंट था सर कल, और मेरा अटेंडेंस कल का सर एब्सेंट दिखा रहा है, ऐसा का है?
क्या नाम?
यस सर।
प्रियांश राज सर।
प्रियांश राज?
21 रोल नंबर 24 EC 21।
आए थे कल?
यस सर, कल हम क्लास में प्रेजेंट थे।
बोले नहीं होगे, प्रॉब्लम यही है। बहुत लोग का एब्सेंट कर लगा है, नहीं थे क्लास में लग रहा है। अच्छा
So,
एक
I'm also present.
मिनट, एक मिनट, ये ट्यूटोरियल वाला है। ट्यूटोरियल में नहीं थे क्या क्लास में? तो
जी सर, थे ट्यूटोरियल में भी थे।
ये क्लास वाला है, इधर ट्यूटोरियल वाला है। 2 तारीख का 2 है ना?
हाँ सर।
हम्म, ठीक है।
ये रिकॉर्डेड लेने में सर अटेंडेंस में कुछ वो तो नहीं आएगा? 75% क्राइटेरिया है जो।
नहीं, ये वाला मुश्किल है।
सर मैं वो ले रहा हूँ, पूरे असाइनमेंट भी सबमिट कर रहा हूँ, पर रिकॉर्डेड ले रहा हूँ, लाइव नहीं ले पा रहा हूँ मैं।
ठीक है ठीक है, चलेगा। अटेंडेंस जस्ट ऐसे ही ले रहे हैं, जस्ट फॉर योर कंफर्मेशन कि हाँ मतलब कितने लोग ज्वाइन कर रहे हैं। ओके, और कोई इशू
ओके
नहीं।
सर।
अटेंडेंस ये वाला शायद ऑनलाइन वाला कंसिडर नहीं होगा। ठीक है, आप लोग ऑफलाइन में आओगे तो उधर से रेगुलर काउंट होगा। 75% उनमें से लिया जाएगा शायद, जहाँ तक मुझे पता है।